Hello again. Today we are going to talk about section 9.3, talking about mass calculations for chemical reactions. We're going to be talking about mass in grams of one substance and then using it to calculate the mass in grams of another substance. We're going to be pulling back and thinking about chapter 7. We're going to go back to conversion factors, calculating molar mass, and using molar mass as a conversion factor. Yesterday we talked about using mole to mole factors or mole to mole ratios of converting moles of substance A to moles of substance B. And so that's really the new part of this section. We're going to go back to chapter 7 and talk about getting grams of substance A to moles of substance A using molar mass. So that's not anything new. We've done that before. And then at the third part of the problem, we'll be taking moles of substance B and use molar mass to get back to grams of substance B, moles to grams. So that's really not something new either. That's something we did in chapter 7. So we're going to combine what we learned yesterday with moles to moles and combine that with what we knew in chapter 7. Okay, get out your mole diagram. Yesterday we added this mole ratio idea to go from known to unknown. So from one substance A to substance B in our from our balanced equation using those coefficients. So go ahead and pause the video and add to your mole diagram. So we're going to just mirror image the top down to the bottom. So now our unknown grams, we use molar mass to get from moles of unknown. And we can also go from moles to particles, same way we did on the top. So the top and the bottom are mirror images of each other. Remember, this mole diagram is like a roadmap that shows us where I'm going to start and where I'm going to end and how many steps I'm going to take. For the most part, we're going to start here with grams of known. We'll use molar mass to get us to moles of known. Then we'll take moles of known, we use the mole ratio or the mole factor to get us to moles of unknown, substance B. And then we'll use take moles and use molar mass again to get us to grams of the substance B, the unknown. So here in our first sample problem, it says that acetylene, which is C2H2, and we're going to undergo combustion, burns in oxygen. It's used in welding cutting torches. So here's the balanced equation. Acetylene and oxygen produce carbon dioxide and water. So the question then becomes, if I have 54.6 grams of acetylene, how many grams of carbon dioxide are produced? So C2H2 then becomes our known, and CO2 becomes our unknown. So looking here at what we know, we're known, our given is 54.6 grams of C2H2, and what we need, what our unknown is grams of CO2. So we're going to need to get to moles of both things. So we're going to need molar masses of both substances, and we're going to need a mole to mole ratio to get us from moles of C2H2 to moles of CO2. So the first thing I'm going to do is we're going to find the molar masses. I'll review that with you, finding molar masses of the two substances. So I'm going to start with C2H2. So remember, we have carbon, we have 2 of those. Hydrogen, we have 1 of those. We use our periodic table. Carbon is 12.01, hydrogen is 1.01. Multiply those together. Oh, sorry, that should be 2 hydrogens. Multiply those together and then add them, and we get 26.04 grams per mole. for C2H2. The other substance we've got is CO2. So we'll need its molar mass. So we have 1 carbon and 2 oxygens. Carbon again is 12.01, oxygen being 16. Multiply those and add them together, and we get 44.01 grams per mole. So here's our plan. We're going to take grams of C2H2 and use the molar mass of C2H2 to convert us to moles. So we just found the molar mass of C2H2, and that is 26.04 grams per mole. So once we use the molar mass here to cut us to moles of C2H4, and then moles of C2H2, moles of known to moles of unknown, we're going to use the mole to mole factor, which uses the coefficients from our balanced equation. And then that will get us to moles of our unknown. Once we have moles of unknown, then we're going to use molar mass to find grams of CO2. This time we're going to use a molar mass of CO2, which we found to be 44.01 grams per mole. So we're going to need 3 conversion factors and 3 steps to find this problem. Okay, now we're ready to start our problem. So we're going to start with the number in the problem. So we're going to start with our 54.6 grams of C2H2. And our first conversion factor we said was going to be the molar mass of C2H2 to convert us from grams to moles. So we want moles. So I'm going to put 1 mole on top. And then on the bottom, I'm going to put the 26.04 grams. All right, so that's going to be my first step. So then I would take the grams of C2H2 would cancel, and I would take 54.6 divided by 26.04, and that gives me moles of C2H2. But I'm not done. I need another conversion factor. So the second conversion factor we said was going to be the mole to mole ratio. So we need the coefficients from our balanced equation. So we're going to use 2 for C2H2 and 4 for CO2. So which one goes on top? It's always the unknown on top. So I want CO2. So I want moles of CO2, and I want to get rid of moles of C2H2. So I'm going to use my coefficients. I'm going to use a 4 for the CO2 and a 2 for the C2H2. Then moles of C2H2 will cancel. I'll have to multiply by 4 and divide by 2. Then then the last conversion factor is going to be the molar mass of CO2. So go from moles of CO2, get rid of moles, and we want grams. So this time I'm going to put the molar mass on the top so that I can get the grams. So I'm going to put 44.01 grams of CO2 over 1 mole of CO2. So now moles of CO2 cancel, giving me the grams of CO2, which is what I wanted. So then looking at the whole problem, I see I've got 54.6 grams. I'm going to divide by 26.04. I'm going to multiply by 4. I'm going to divide by 2. Then multiply by 44.01. And then I come up to be 185 grams of CO2. Looking at my significant figures, I see I have 3 significant figures here. My molar mass both have 4 significant figures. Mole ratios are exact numbers, so I'm looking for the least number of significant figures. So back here is 3, so my answer can have 3 significant figures. So I'm going to do another example problem. This time we're talking about the fuel heptane. It's used in gasoline. So the question is, how many grams of oxygen are needed to react with 22.5 grams of heptane? So it's again a combustion reaction. So we have the heptane reacting with oxygen to produce carbon dioxide and water. And they've gone to the trouble of balancing the equation for us with 11 O2s, 7 CO2s, and 8 H2Os. So here's going to be our plan. We're given the 22.5 grams of heptane, that's our known, and grams of O2 are our unknown. So we're going to start with grams of known. First step is going to be molar mass of C7H16. That's going to be our first molar mass, and that'll give us to moles of heptane. Then we'll use our mole to mole factor or our mole ratio to get us from moles of known to moles of unknown. Then the third step will be moles of O2, use molar mass to find grams of O2. So the first thing we want to do is find the molar masses. So we'll find a molar mass of C7H16. So carbon, we have 7. Hydrogens, we have 16. Carbon, looking at our periodic table, 12.01. Hydrogen, 1.01. Multiply those out, add the two together, and you should get 100.20 grams per mole. Then mole to mole factor, again, that's going to use our coefficients. And then moles of O2, finding the molar mass of O2, oxygen, 2 of those at 16. So that adds up to be 32 grams per mole. So here's our plan for problem number 2. We're going to start with the 22.5 grams of heptane. And the first conversion factor is going to be moles of heptane over molar mass of heptane. And then the second conversion factor is going to be our mole ratio, unknown of O2 over known of C7H16. Coefficient in front of O2 is 11. Coefficient in front of C7H16 is 1. Then my third conversion factor is going to be molar mass of O2. I want grams, so that goes on top. I'm canceling moles of O2, so that goes on the bottom. So when I do all that, after I have all that set up, I'm going to take 22.5, divide by 100.02, times 11, times 32, and I get 79.1 grams of O2. Looking at significant figures, I start with 3 significant figures. Molar mass has 4. Mole ratios are exact. Molar mass again has 4. So I go back, I'm going to have 3 significant figures in my answer.